I am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. Welcome to the lecture session of image processing. In this session, we will see enhancement using arithmetic and logical operations. So the topics we are going to cover in that are arithmetic operations. So in that arithmetic operations, we will see different types like performing addition of images, subtraction of images, multiplication of images and division of images. And next we will look after logical operations. So in this logical operations, we will discuss about different logical operations like AND operation, OR operation, NOT operation, and also we will see applications. That means addition of images can be applied in which cases, or AND operation can be applied on which images. So we will see in this applications topic, and we will also see some examples how to perform addition between images and what will be the result of that images. So not only addition, all these operations, how it will be performed on the images and how we are going to get the resultant image. So all these topics comes under image enhancement. So first thing is, what is meant by image enhancement means improving the quality of the image is image enhancement. So in order to do that, we are going to apply different arithmetic and logical operations on the image. And here we will see first arithmetic operations. So what are arithmetic operations? So arithmetic operations in the image processing involve manipulating pixel values by performing some mathematical operations on corresponding pixels of two images. So in order to perform addition or subtraction or multiplication or division, whatever arithmetic operation is, compulsory here, two images are required. So we have to perform the arithmetic operation between the two images. Here images will be represented in the form of pixels. Operation should be done based on pixels only between two images. So here the basic four arithmetic operations we are going to see are addition, subtraction, multiplication and division. So these arithmetic operations are used to enhance the image, reduce the noise, and we can also perform some transformation techniques on the image. Now we will see each arithmetic operation in detail. Now, so these operations are applied on pixel by pixel basis. So pixel by pixel basis means, for example, if we consider this is image 1 and this is image 2 and here this is the output image. So here the operation should be performed between these two images pixel by pixel basis. So here that operation may be here addition operation or subtraction operation or multiplication operation or division operation. Any arithmetic operation can be applied between these two images, but it should be applied on pixel by pixel basis only. So here image, if you consider here, these are all the pixels that are available here. So on the image we can consider it 0, 0 and this is 0, 1, 0, 2, and if you consider here in image 2 the pixel 0, 0, 0, 1, 0, 2. So operation should be done on pixel by pixel basis. That means this pixel 0, 0 of image 1 should be added with the pixel 0, 0 of image 2 only. Then the result what we are getting is 0, 0 and it will be represented in the output image result. After that, we have to perform that arithmetic operation between another pixels, that is 0, 1 of one image, first image, and 0, 1 of second image. Then what we will get here is the new pixel of 0, 1 in the resultant image. So here we should perform arithmetic operation between the value 0, 0 in image 1 with the pixel value 0, 0 in image 2 and store the result at pixel 0, 0 in the new image. So this is the example. So in order to move to the next pixel and repeat the process, continue until the entire pixels are visited. So like this we have to perform operation on each pixel in the image until we reach the last pixel. So while performing this operation, we have to see that the dimensions of both the images should be same. For example, if we are considering this is 3 by 3 image, so we have to also see that image 2 also should be of same dimensions, that is 3 by 3. So this is the important point we have to look while performing the arithmetic operation between two images. So we have to make the operations on identical images having identical dimensions only. So if the image have different dimensions also, no problem, but different transform need to be applied in order to make them equal. Then only the operation will be performed. Now, so in the arithmetic operation, the first operation is addition operation. So how to perform addition operation between two images? Here the addition operation should be performed between the two pixel values of the two images and we have to add, that means pixel value of image 1, that is 0, 0 should be added with the pixel value 0, 0 of image 2. So here while performing this operation, we have to follow some rules in order to get the result. What are that rules means? So while performing addition operation between two pixels of two images, the result may be integer value or sometimes we will also get the floating point value. So if you are getting floating point value, we have to round off that particular floating point value in order to get the integer value. So this is one rule. And for example, another condition also we may get, the result may be greater than the range. Range means here, if we consider 8-bit grayscale image 2 power 8, how many number of levels we are going to get? Maximum 256. So it will be ranging from 0 to L minus 1, that is 0 to 255. So in this case, this 0 is the minimum value and 255 is the maximum value. So while performing addition operation between two pixels, there is also chance in order to exceed this maximum range. In such case, when you are performing addition operation, if it reaches or if it exceeds the maximum range, we have to consider that value as the maximum range 255. So minimum value will be 0. For example, if you add any two numbers and if you are getting a result as in terms of negative, in case we have to make it as the minimum value 0. So these are the rules we have to follow while performing addition operation between images. So in which applications we can use this addition operation means in the case where noise reduction is required and image averaging also. Now, so we can clearly understand this addition operation if we look after this example. So this addition operation can be represented with the equation g of z comma y is equal to f1 of x comma y plus f2 of x comma y. So here f1 of x comma y represents image 1 and f2 of x comma y represents image 2. If we perform here addition operation between these two, we are going to get the result which forms the new image, that is g of x comma y. So let us consider here this is f1 of x comma y and this image is f2 of x comma y. So addition operation should be performed between pixel by pixel until all the pixels are completed. Following the rules we have to perform. So here first one is 0, 0. In this case initial value is 0. In image 2 the first value is 10. So 0 plus 10, the result is 10. And the next pixel of image 1 is 100. Image 2 is 180. So if you perform 100 plus 180, the result will be 280. In this example, we have considered is 8-bit grayscale image where the maximum possibilities are from 0 to 255. But if we add these two pixels, we are getting 280, which is above this range 255. So we have to make this 280 equal to 255. That is applying the rule what we have learned in the addition of two images. So that's why here we have written as 255. And next pixel is 10 plus 5. We are going to get here 15. And the next pixel 4 plus 2 is 6. 0 plus 0 is 0. And 10 plus 0 is 10. And here 8 plus 0 is 8. 0 plus 10 is 10. And 5 plus 10 is 50. Except this value, all the other values are within this range only. So for this value only we are getting 280, which exceeds the limit. So we have rounded that to 255. So this is how we have to perform addition operation until unless all the pixels are completed. Now, so this is the image that we can observe. If we perform addition operation between two images, image will be represented in the form of pixels having its own intensity level as we have seen in the previous example. So if we consider this is image 1 and image 2, if you apply addition operation between these two images, then the new image will be formed, that is image 3, including these two. And the next arithmetic operation is subtraction of images. Same like addition, we have to perform subtraction operation between between the pixels of two images. So subtraction of images involves subtracting corresponding pixel value from one image. So while doing subtraction operation, the result may be 0. If it is 0, no problem. Sometimes the result may be negative. So in such cases, we have to make it as the minimum value, that is 0. We have to apply the rules. So in which applications this subtraction of images can be applied means for image enhancement or in order to detect the difference between two images, in some medical imaging for mask mode radiography. So in such applications this subtraction of images will be used. Now applying these rules, we will see one example how to perform subtraction operation between images. So consider f1 of x comma y is image 1 and f2 of x comma y is image 2. if you perform subtraction operation between these two images, then the new image is going to get as a result, that is g of x comma y. So f1 of x comma y is represented in the matrix and f2 of x comma y is represented in the matrix. If you perform subtraction operation between these two, so here first pixel of image 1 is 0, first pixel of image 2 is 10. So if you perform 0 minus 10, the value will be minus 10, which is in terms of negative. So as we have considered in this example, 8-bit gray level image, so the levels will be maximum 255 and minimum is 0. So in case if we are getting like this any negative values, we will consider it as the minimum value, that is 0. All these are the rules we have to apply while performing subtraction of images. That's why here we have written as 0 instead of minus 10. And 100 minus 180. So in this case also 100 minus 180 we will get minus 80, which is in terms of negative. So negative means we have to round it off to the minimum value, which is 0. So 10 minus 5, the result is 5, no problem here. Next value is 4 minus 2, result is 2. 0 minus 0, result is 0. And 10 minus 0, the result is 10. In this column also, in this row also there is no problem. 8 minus 0, the result is 8. And 0 minus 10, again here we are going to get minus 10. So we have to round it off to the minimum value. We have to make it to the minimum value, that is 0. And 5 minus 10 is also minus 5, which is negative. So we have considered it as a minimum value, that is 0. So like this we have to apply all the rules in order to perform subtraction between images. So this is the example. We can see here clearly the images. This is image 1 and here is image 2. If we subtract this image 2 from image 1, we are going to get the new image as a result. And next arithmetic operation is multiplication of images. Now, so multiplication also should be performed for all the pixels in both the images, same as addition and subtraction, and the result, whatever we are getting after multiplication, the result need to be managed by applying some rules. What are the rules means here? When you are multiplying any two intensity values, the result may be greater than the limit. So here we have considered 8-bit grayscale image. So the limit is from 0 to 255. If we perform multiplication operation, sometimes the result may be greater than 255. In such case, we have to limit that to the maximum value, that is 255. So if the result exceeds the pixel range, it is set to the maximum value, that is 255. Now, so in which applications we can use this multiplication operation means, whenever we are going to adjust the brightness of the image, we can apply this multiplication of images. And for shading correction and masking or region of interest operation, that means if we are going to concentrate only on particular part of the image, we can have this multiplication of images. So if you perform multiplication on images, what we are going to get means, it is going to brighten the image. So that we can see in the example also. So now let us consider this example and see how to perform multiplication operation between two images. So consider here f1 of x comma y is image 1 and f2 of x comma y is image 2. If we perform multiplication operation between these two images, we are going to get the result, which is the new image g of x comma y. So this multiplication of images concept is represented in this, in the form of this equation. Now let us consider here two images are given in terms of matrix. Perform multiplication operation between the two pixels, same as addition and subtraction. Then we are going to get the new image. So here the first value is 0 into 10. 0 into 10 means the result will be 0. So here 100 into 180. So if the 100 into 180, if we do, the result will be greater than 255. In such cases, we have to limit that to the maximum value, that is 255. We have applied the rule here. And next one is 10 into 5, result is 50. 4 into 2, result is 8. 0 into 0, result is 0. And 10 into 0, result is 0. And 8 into 0 is 0. And 0 into 10 is 0. And 5 into 10 is 50. All the pixels, we have applied multiplication operation. So only we got problem when we are multiplying these two pixel values. We have applied the rule here and we have changed that value to 255. So like this we have to perform multiplication operation on images. So let us see this picture. So if you perform, we have seen one point, if you perform multiplication operation with some factor on the image, the brightness of that particular image will be enhanced. So this is the original image. After performing the multiplication operation for this image by some factor, the brightness of the image will be improved. The next arithmetic operation is division of images. So division of images should be done on related pixels. So pixel of image B and pixel of image A should be considered. So if the result, while performing the division operation, sometimes we may get the value infinity as a result. In such cases, we have to apply the rule and make that infinite value equal to 0. So whatever the value we are going to divide, that particular value should be greater than 1. If we perform division operation for any image with a factor which is greater than 1, the quality of the image will be reduced. That means the output image will be darkened compared to the original image. Now, applying these rules, let us solve one example. Before that, if we see this image, so this is the original image. After applying the division operation by some factor, that particular image will get darkened. If you perform multiplication, so here is the clear difference. If you perform, considering original image, if you perform multiplication operation by a factor 2, it has been brightened. And if you perform division operation by a factor 2, it is darkened. So this figure clearly shows the example of multiplication and division of images. Now, so let us solve one simple example, division of images. So f1 of x comma y is image 1 and f2 of x comma y is image 2. If we perform division operation, then we are going to get the output image which is g of x comma y. So here 0 by 10, the value will be 0, no problem here, no rule need to be applied. And next one is 100 by 180. So here 100 by 180, if you do, the value will be 0.55. So as the value is 0.55, which is not infinity, we have to round it off to the nearest integer. That's why we have got here 1. So in this case, the rule is applied. And next one is 10 by 5. the value will be 2. So here the rule is applied. Next value is 4 by 2, the value is 2, and 0 by 0, the value is 0, and 10 by 0, 10 by 0 means, at least we have seen, we have discussed the rule, the factor with what we are dividing should be greater than 1. So here 10 by 0 means the result is infinity, so we are going to make it to the minimum value, that is 0. So in this case also the rule is applied, and 8 by 0 is again infinity. So in this case also the rule is applied, we have made it to the minimum value. 0 by 10 is 0, and 5 by 10, here 5 by 10 we will get some 0.5, we have rounded it off and we are getting here 1. So this is how we have to perform division operation. And all these are the 4 basic arithmetic operations. Next, coming to the logical operations, here we are going to see 3 logical operations: AND, OR and NOT. Same as arithmetic operation, this operation also should be performed pixel by pixel. So it is commonly used in digital logic and design. That means here we are going to perform this AND or NOT operations only on digital images, which will be represented only in terms of zeros and ones. So we know what happens when AND operation is performed between 2 values. It is based on the truth table of AND gate. So for AND gate, when both the values are 1, the result will be 1. In another cases, it will be 0. And for OR, at least if one input is 1, the result will be 1. Otherwise, it will be 0. And NOT operation, 0 will be changed to 1 and 1 will be changed to 0. So this AND or NOT operations applying to an image means we are going to apply mask. That means here these logical operations will be used only when we are going to perform operation on one particular part of an image, which is called region of interest from an image. So now let us see about each logical operation on the image. First operation is AND operation. So AND operation will be performed between each pixel pairs. So if both the pixels are 1, then the output will be 1 according to the truth table of AND gate. Otherwise it will be 0. Now, so where this AND operation of an image can be applied means, in order to extract the common features from multiple images, this AND operation can be applied. So this is the original image. If you use this AND image mask, so here there will be a mask, window is available here, and we are going to get resultant image after performing this AND operation. In this mask only, we will get this entire image. So let us see one example. These logical operations will be applied only for binary data, that is digital data. So here that's why this f1 of x comma y and f2 of x comma y, what we have taken are completely in terms of zeros and ones, no other values are here. So according to the truth table of AND gate, perform operation on pixel by pixel, that is 1, 0. For the AND gate, both the values should be 1, otherwise it will be 0. So that's why here we got 0, and 1, 1 both are ones, so the result will be 1. So 0, 0, the result will be 0 following the truth table of AND gate. So here 0, 1 is 0, 0, 1 is 0, last 1, 0 is 0, and next one is 1, 0 is 0 because both should be ones. So 0, 0 is 0 and 1, 1, both are ones here for the AND gate, so the result will be 1. So like this we have to perform AND operation between two images. Coming to the next logical operation, that is OR operation. Same as AND operation, it should also be performed between corresponding pixels of two images. So, according to the truth table of OR gate, if any one of the input is 1, output will be 1. When both are zeros, output will be 0. So, applying that, this AND operation will be performed between the images. So, here this is the original image, and OR image mask means we can see here this image is darkened, and this is the mask of OR image. If you perform OR operation on this original image, then this is the resultant image. So, in this mask, we have that image, whereas the remaining thing is bright. So, consider here f1 of x comma y is in image 1 and f2 of x comma y is image 2. If you perform OR operation between these two images, then the resultant image is g of x comma y. So, according to the truth table of OR gate, performing between two pixels, so 1 0, at least there is 1, so the result is 1. Next one is 1 1, both are 1, so the result will be 1, and 0 0, the result is 0, and here 0 1, 1 is there, so here you will get 1, and 0 1, we will get 1, and 1 0, the result is 1. So, like this, 1 0, the result is 1, and here 0 0, the result is 0, and here 1 1, the result is 1. So, like this we have to perform OR operation between images. And finally, the last logical operation is NOT. So, the NOT operation is performed on the single image. So, here we will have only one image, that is f of x comma y. On that only we have to perform the NOT operation. So, inverting the pixel values, that means that image may consist of different pixel values. It will be represented as 0 or 1. When we perform NOT operation, 0 will be changed to 1 and 1 will be changed to 0. So, if the input value is 0, the output will become 1 and vice versa. So, in which applications this NOT operation can be used means, it can be applied for image manipulation and conversion. So, this is what about arithmetic and logical operations on images. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.